Everyone, good afternoon, right? Good morning or good afternoon. I think I'm audible, right? Good afternoon, good afternoon. Okay, so we are in 14th lecture of ODE, where we're going to move on to the second topic, which is second and higher order linear differential equations with the constant coefficients, right? So in the very first class of ODE, I have given you the syllabus, right? I given you the syllabus. So we have completed one topic. We have completed one topic, which is the differential equations of solving a differential equation of first order and first degree. Right? This is the notes of the very first class. Even the syllabus, right? So in this syllabus, we have started with the first topic, which is equations of. We will complete this topic later. That is formation of differential equations. So we have completed this topic, right? Equations of first order and first degree, integrating factors. That there are many methods to solve the differential equations of first order, right? First order and first degree. We have given you there are many methods, right? Variable separable method, homogeneous, linear differential, exact differential, and so on, right? Okay. So these are the methods that you solved using. These are the methods to solve to differential equation of first order and first degree. From lecture number 1 to lecture number 13, we have completed this topic. Now we are going to move on to second topic, right? Which is called second and higher order linear equations with the constant coefficient, particular integral, and general solution. Right? This is the topic that we are going to do now, right? We will come to this topic later. That is equations of first order, but not of first degree. We will come to this topic later because for solving this, we need the idea of this. That means, so we are going to move on to the second topic in ODE, which is second and higher order linear equations with the constant coefficients, complementary functions, particular integral, and general solution. Right? So very easy topic. So we will complete this topic very quickly, maximum in 3 to 4 videos. I can complete. I think I can complete this topic. After that, we'll move on to next topics. Right? So we're going to start second and higher order linear differential equations with the constant coefficients. Right? With constant coefficient. So we will start. Is it clear, right? So first topic that we have seen is solving a differential equations of first order and first degree. That is lecture number 1 to lecture number 13. Now we'll move on to lecture number 14, where we're going to introduce what is meant by second and higher order linear differential equations with the constant coefficient, right? Okay. The first what we'll do is I will give you what I will tell you what is meant by linear differential equations, right? Linear differential equation. So we'll start. Linear differential equations, right? Okay. So a linear differential equation is of the form a linear differential equation is of the form, right? I'm going to tell you the form of a linear differential equation, right? This is given by a naught dn by dxn, right? That is the nth order derivative of y. A naught, right? A1 dn minus 1y divided by dx n minus 1 and so on, right? A2 dn minus 2y divided by dx n minus 2 and so on up to a n y is equal to x. This is the general format of a linear differential equation, right? So nth order derivative, n minus 1th order derivative, n minus 2 order derivative and so on up to y is equal to x, right? Where this a0, a1, a2 and so on up to an are constants, right? Are constant. That is what they are set. That is what topic is a linear differential equations of second and higher order the constant coefficients. That is here the a0, a1, a2 all are constants, right? These are all constant. If it is not constant means we will be moving on to the next topic. But now These A0, A1, A2 up to AN are all constants, right? Okay. Linear equations, linear differential equations, constant coefficient. Constant coefficient. I think outside there is some work going on. Is there any noise in the video, like the drilling noise? Okay, this A0, A1, A2 up to AN are constants, and X is a function of, and this capital X is a function of X only, right? It's a function of X only, right? This is called a differential equations of nth order, a linear differential equation of the form. It is a differential. The above is here. The above is a linear differential equation with constant coefficient, of nth order, right? So this is called nth order linear differential equation with a constant coefficient. Usually in exam point of view, we will have second order or third order or fourth order only. Right? In exam point of view, we will have second order or third order or fourth order. Right? For example, how the pattern of a second order, equation will be, right? It will be of the form a naught d square y by dx square plus a1 dy by dx plus a2y is equal to some x, right? This x is a function of x only. This is called a second order linear differential equation constant coefficient, right? This is called second order linear differential equation with constant coefficient. Why I am saying constant coefficient? Because this a0, a1, a2 all are constants, right? Now how the third order will be a0 d cube y by dx cube plus a1 d square y by dx square plus a2 dy by dx plus a3y is equal to x. This is called a third order. This is called a third order linear differential equation with constant coefficient, right? Constant coefficient means this a0, a1, a2, a3 all are constant, right? Suppose if it is variable means we will moving on to the next topic, right? But no problem. As of now, this a0, a1, a2, a3 all are constants. Now the fourth order linear differential equation will be a0 d power 4y by dx power 4 a1 d cube y by dx cube plus a2 d square y by dx square plus a3 dy by dx plus a4y is equal to x. Remember, this x is a function of x. It can be anything, but it has to be a function of x. This is called a fourth order linear differential equations with constant coefficient. From an exam point of view, you will have only a second order or third order, fourth order, right? Fourth order also is very rare, right? Usually you will get in second order or third order only. Now our aim is to solve these kinds of equation. Our aim is to solve these kinds of equation, right? This kind of equation. Now how to solve this kind of equation? That is, we need to find a function y. That y we have to differentiate twice, multiply a0, differentiate y with respect to x once, multiply a1, and y with a2. Overall add it up, you have to get x as an answer. That is, we need to find solution, right? Solution means we are looking for a y that satisfies, that is, we are looking for a function that satisfies this equation. So how to find solution of this kinds of equation? So in exam point of view, we can what we can do is symbolically, in symbols we can write, right? In exam point of view, instead of writing d by dx, they can also write like this, right? They can also denote d by dx by capital D, right? Yes or no? So in symbols we can write d by dx to be capital D. Therefore, how this will be, how this turns out to be, uh, so in symbols, if I write like this, now this is same as writing a naught d square plus a1 d plus a2 of y is equal to x. This is same as writing this, right? Because is d square by dx square. What is d square? D square is d square by dx square. I'm taking y outside from all, right? And similarly, this is same as a naught d cube plus a1 d square plus a2 d plus a3, take that y outside, is equal to x. Both are same, right? And symbolically, we will write d by dx of d to be capital D, right? So therefore, this one can also be written as, right? One can also be written as, one can also be written as, right? So d is, so I can write dn by dxn as d power n. You just take this y common in all. That means this is same as a naught d power n, an d power n minus 1, a2 d power n minus 2, and so on up to an, right? Up to an of y is equal to. So both are same, right? Both are same. So in exam point of view, if you see capital D, that is same as d by dx. So our aim is to solve these kinds of equation, right? So how to solve these kinds of equation? So we need to solve these kinds of equation, right? Depending upon the RHS, right? Depending upon the RHS, right? RHS is capital X and capital X is a function of X, right? So we're going to put this into many types, right? Type 0, type 1, type 2, type 3, type 4, type 5, and so on, right? So depending upon the value of X, we're going to classify them into different types, right? So before that, the general solution of one will be of the form, the general solution of one will be of the form, will be of the form, right? So a general solution of this equation of nth order of linear differential equation, constant quotient of nth order, will be of the form y is equal to, y solution, right, is given by complementary function, right? Complementary function plus particular integral. So we need to find these two and then we need to add it up, right? We need to add it up to find solution of y, right? So we can also write this as in short form CF plus PI, right? So a general solution of a linear differential equation. Why I'm saying linear? Because the degree is one for all, right? So you can say even though it is nth order, but degree is one. That is whole power, right? Whole power is one. Whole power is one for all. So we're going to call that as linear, right? Okay. So a solution will be of the form y is equal to CF plus PI, right? CF plus PI. Now we need to find complementary function and particular integral, right? Particular integral. We need to add it up to find a solution, right? Okay. For all x, right? So whatever RHS may be, right? Whatever RHS may be, the method of finding the complementary function is same for all, right? Whatever the RHS may be, right? That is whatever the function of x, whatever x may be. So whatever RHS may be, right? That is x, right? X is a RHS, right? This is a function of x. This is a function of x. Whatever RHS may be, the method of finding the complementary function, the method of finding complementary function is same, right? So whatever RHS may be, it can be sin x, it can be cos x, or it can be e power 2x, or it can be x into e power 2x, whatever RHS may be, the method of finding the complementary function is same, right? So how to find complementary function? The complementary function, now I'm going to tell you the method of finding Method of finding complementary function. I have said to you that whatever the RHS may be, right? R is a function of x. Whatever the RHS may be, the method of finding the complementary function is same for all RHS, right? So how to find complementary function is, right? So first we need to form the so we have, right? So we have, let us take an example, right? Okay, so we have what is the equation here? dn a naught dn plus a1 dn minus 1 and so on up to an of y is equal to capital S. This is the differential equation of nth order, right? But usually we will have what? Second order or third order or fourth order, right? Now what I'm going to do is form the auxiliary equation, right? Form the auxiliary equation. So how to form auxiliary equation is just replace this d by m, right? That means this is the auxiliary equation, right? You omit y. In this you replace d by m. So we have a naught m power n plus an m power n minus 1 and so on up to an, right, is equal to 0 and equal to 0, right? You consider this equation, replace d by m and equal to 0. What is this? Which is a polynomial. Now this is a polynomial, right? Which is a polynomial of degree n. Which is a polynomial of degree n. Usually you will have second order. I think you have some problem. Okay. I think there is some problem in right. Okay. Okay, so we write again. So for finding the complementary function, consider the nth order linear differential equation, right? With constant coefficient a naught dn an e power n minus 1 and so on up to an of y is equal to capital X, right? The first form the auxiliary equation, right? So to form auxiliary equation, you replace this capital D by m and you equate this term to be equal to 0, right? You equate this term to be equal to 0. So you will have a naught m power n plus a1 m power n minus 1 and so on up to an is equal to 0, right? Which is a polynomial of degree n, which is a polynomial of degree n and we'll have n roots, right? And we'll have n roots and we'll have n roots, right? So depending upon the nature of roots, you need to write the complementary function. Depending upon the nature of roots, you need to write the complementary function, right? So which is usually we will have second order or third order or fourth order. If it is second order means we will have two roots, right? Because it is a polynomial equation of degree 2. Or we can have a third order. If it is third order means you will have a polynomial degree 3. That is the auxiliary equation will be a polynomial of degree 3. In that case you will have 3 roots. If it is fourth order means it will be a polynomial of degree 4. In that case you will have 4 roots, right? So in exam point of view, you're going to get whether second order or third order or fourth order. If it is second order means you will have 2 roots. If it is third order means you will have 3 roots. If it is fourth order means you will have 4 roots, right? Okay. So depending upon the roots, we need to write the complementary function, right? We need to write the complementary function based on the roots, right? Okay. So write it down. A minute. So far what we have said is the solution of this equation is given by y is equal to complementary function plus particular integral. Complementary function, the method of finding complementary function is same for all x, right? Whatever RHS may be, the method of finding complementary function is same How to find complementary function is you just replace this capital D by M and equate this to equal to 0. So you will have a polynomial of degree n, right? Which is a polynomial in M. You will have polynomial equation of degree n. So you will have n roots, right? So depending upon the nature of roots, I'm going to write down a complementary function now, right? A minute. Okay. Okay, now I'm going to write down the formula for finding the complementary function, right? Okay. So roots of auxiliary equation. Corresponding is the characteristic function. Right? Characteristic function and characteristic solution. So first is, suppose if we have two real and distinct roots, right? Two real and distinct roots. Two real and distinct roots. Let us say m1 and m2, right? So if you have two distinct real roots, the characteristic function is given by c1 e power m1x plus c2 e power m2x. This table is very important, right? So if you have two distinct real roots, the characteristic function is c1 e power m1x plus c2 e power m2x. m1 and m2 are the roots. Okay. So if you have two real and equal roots, two real and equal roots, right? That is when you are solving, you are getting the same roots, right? Say m1, m1, right? If you have any roots like m1, m1, the characteristic function is given by c1 plus c2x into e power m1x, right? m1 is the root that you are getting as equal roots. c1 plus c2x into e power m1x. Suppose this can also be extended for three roots also, right? Suppose you have three distinct roots, means m1, m2, m3. We will have c3 plus e power m3x, right? So okay, let's write three real and distinct roots. Let us say m1, m2, m3, right? So this is same as 1 and 3 are same, right? In that case, the complementary function will be c1 e power m1x. Okay, what I will do is I will write it down here, right? So that you will have more clarity when you are studying. So three real and distinct roots. So three real and distinct roots. So let's say m1, m2, m3. What about the characteristic function will be? It will be c1 e power m1x, c2 e power m2x, c3 e power m3x, right? Suppose if you have two real and equal roots, right? If you have two equal roots, let us say m1, m1, right? In that case, your complementary function will be c1 plus c2x into e power m1x, right? Suppose if you have three real and equal roots, three real and equal roots, right? Let's say m1, 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 right? So in that case, your complementary function will be c1 plus c2x plus c3x square into e power m1x, right? So here you have c1 plus c2x, you extend to c3x square because you have three roots, equal roots. Now there is some disturbance outside, so please adjust with that, right? I think we will finish quickly. Okay, so we have one pair of complex roots, right? one pair of complex roots. Let us say the roots are alpha plus or minus I beta, right? Alpha plus or minus I beta. So if you have one pair of complex roots, alpha plus or minus I beta, your complementary function is e power alpha x into c1 cos beta x plus c2 sin beta x, right? Suppose if you have two pairs, suppose if you have two pairs of complex roots, right? That is um, alpha plus I beta, um, two pairs of distinct complex roots. If you understand this table, the problem solving is very easy. Two pairs of distinct complex roots, right? So alpha plus or minus I beta, and let us say the other roots are gamma plus or minus I delta. So in that case, what will be your complementary function? E power alpha x, c1 cos beta x, c2 sin beta x plus e power gamma x, c3 sin delta x plus c4 sin delta x. The last is if you have two pairs of equal complex roots, right? If you have two pairs of equal complex roots, alpha plus I beta, alpha plus or minus I beta. So in that case, your complementary function is e power alpha x, c1 plus c2 x into cos beta x plus, in not visible if I write here, plus c3 plus c4x sin beta x, right? This is the solutions of the complementary functions, right? To understand this table, then problem solving is very easy, right? So you understand these 7 parts, right? So that is if your roots are real and distinct, right? If your roots are real and distinct, right? If you have two distinct real roots, the complementary function is c1 e power m1x plus c2 e power m2x. If you have three real and distinct roots, how these m1, m2 are obtained? This is obtained by solving the auxiliary equation. What's auxiliary equation? In the nth order differential equation, you replace this capital D by m. So you will have a polynomial of degree n, and this will have n roots. So depending upon the roots, these are the possibilities of the roots. You have to write the complementary function based on that. Is it clear up to now? Clear up to now? Those who are watching. So we are solving a differential equations of nth order. The solution is given by complementary function plus particular integral. Particular integral is to be found. I think I'm getting lots of disturbance outside. Is it clear up to now? So to find a complementary function, we need to solve this polynomial equation of degree n. Based on that, we define the complementary function, right? And to find particular integral, so refer next table for finding the complementary function, right? Now how to find method of finding complementary function, right? Now how to find particular integral? Method to find in table 6, no, C3 and C4 both in the okay, it will be cos, sorry, be cos. cos delta x plus c4 sin delta x. Okay, thank you. Okay, so to find particular integral, see, for complementary function, method of finding is same for whatever RHS may be. So depending upon the RHS, right? The method of finding the particular integral will vary, right? So I will just write this. So depending upon the RHS that we go now, what we're going to do is we're going to classify different RHS. So type 0, type 1, type 2, type 3. Depending upon the type, the method of finding particular integral will vary, right? The method of finding particular integral will vary, right? Is it clear up to now? The solution is y is equal to complementary function plus particular integral. The method of finding complementary function is same for all. For finding particular integral, we need to find depending upon the RHS that we're going to do in the next parts, right? Is it clear up to now? Okay, so we'll move on to type 0, right? Now what is type 0 is this cos, right? Cos delta x plus c4 sin delta x. Okay, now we'll move on to type 0. So type 0 will be, that is for finding particular integral, I said it will vary depending upon the value of x, right? That value of x, we're going to classify them into different types. The first is type 1. RHS is 0, right? That is you have x is equal to 0. That we're going to solve now. If RHS is 0, the solution is given by y is equal to complementary function alone, right? You don't have particular integral. If your x is 0, the solution is y is equal to complementary function. Usually we will have the solution is y is equal to cf plus pi. But if we, okay, let us call this type 0, right? So in type 0, the RHS is 0. That is the x term is 0, right? Solution is given by y is equal to complementary function alone. You don't have plus pi when your RHS is 0. Is it clear? Now we'll move on to solving the problems, right? Problems. We are doing problems on type 0. RHS is 0. Right? Solve d square y by dx square minus 3 into dy by dx minus 4y is equal to 0. Now we can see clear this is type 1. Why? This is RHS is 0. RHS is 0 and this is a third order linear differential equation with constant coefficient. Sorry, second order, right? It is second order linear differential equation with a constant coefficient and this falls under type 0. It falls under type 0. Why type 0? Because your RHS is 0. Right? This is same as writing d square minus 3d minus 4 of y is equal to 0. Right? The solution is given by y is equal to complementary function alone. Right? We don't have plus pi. How to find complementary function? You just find the auxiliary equation. Depending upon the roots of auxiliary equation, you need to write complementary function. So we have auxiliary equation to be equal to m square minus 3m. You just replace d by m. So you will have m square minus 3m minus 4 is equal to 0. Right? Solve this equation. So m is equal to minus b plus or minus root of b square minus 4ac by 2a. So it will be 3 plus or minus root of b square minus 4ac divided by 2 times a. So it is like 3 plus or minus 9 plus 16 is 25. Root 25 is 5 divided by 2. So 3 plus 5 by 2. 3 minus 5 by 2. We will have 8 by 2 is 4. Minus 2 by 2 is minus 1. That means the roots are real and distinct. right? That means what will be the characteristic function roots are in distinct? It is given by c1 e power m1x plus c2 e power m2x. Now what is m1 m2 here? This is your m1 and this is your m2. So it will be c1 e power 4x plus c2 e power minus 1 into x. Therefore, the solution is given by y is equal to c1 e power 4x plus c2 e power minus x. So we don't have any initial data to find c1 c2. In that case, you can keep the solution as it is. Right? This is a required solution. Is it clear? If you understand one problem, you can do any problem in type 0. Type 0 is first you see whether it is linear differential equation with constant coefficients, right? The coefficients are constant here, and you see whether RHS and you see which type it falls under. So type 0 is if your RHS is 0, then it is called type 0. Is it clear? And move on next problem. Is it clear? We'll move on to next problem. So solve. So for type 0, solution is CF alone, right? So solve d cube by dx cube minus 7 dy by dx minus 6y is equal to 0. Now you can see it is a linear differential equation of third order, because we have third order with constant coefficients, and it falls under type 0. It falls under type 0 because the RHS is 0. RHS is 0. This is same as writing d cube minus 7d minus 6 of y is equal to 0. Right here, the second order is missing. Second order derivative is missing. No problem, right? That quotient is 0. So d cube minus 7d minus 6 is equal to 0. Now we need to solve this equation, right? The solution is given by y is equal to complementary function alone. Usually we'll have particular integral will be added up with it, but since it is type 0, the complementary function is the solution is given by y is equal to CF. Okay, now to find CF, first you find the auxiliary equation, right? What is the auxiliary equation here? M cube minus 7m minus 6 is equal to 0. So you need to find the roots. You will have 3 roots, right? By fundamental theorem of algebra. Now you can see clearly m is equal to 1 is a root, right? Minus 1. Yes, clearly minus 1 is a root, right? Because we put m is equal to minus 1 here. So minus 1 whole cube is minus 1. This will be plus 7. 7 minus 1 is 6. 6 minus 6 is 0. So to find other roots, find by L method, right? Direct division. This is very simple. We are just solving a third order equation, third degree equation. So m cube, m square, there is no term, right? These are the quotient of m cube, square, m, and constant term. There is no m square term here, so just put, don't forget to put 0, right? So you need to put 0 first here. So 1 plus 0 is 1, right? Minus 1, 1 is minus 1. 0 minus 1 is minus 1. Minus 1 minus 1 is plus 1. Minus 7 plus 1 is minus 6. Minus 1 minus 6 is plus 6. So we will have this to be 0. The other two roots are found by solving this equation, right? You see this as a quadratic. So you will have m square minus m minus 6 equal to 0. This is quotient of m square, this is quotient of m, this is quotient of constant term. Find the roots here. Is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. 1 plus or minus b square minus 4ac. So 20 minus 24, this will be plus 24, this will be root 25. Root 25 is 5 divided by 2. So 1 plus 5 by 2. 1 plus 6 by 2, which is 3. 1 minus 5 by 2, which is minus 4 by 2, which is minus 2. Right? So therefore, the roots are minus 1, minus 2, and plus 3. All are distinct. Right? Therefore, the complementary function is given by C1 e power m1x, c2 e power m2x, c3 e power m3x. Therefore, the solution is given by y is equal to complementary function. So m1 is minus x, m2 is minus 2x, m3 is 3x. This is the required solution. That is, if you put this y here, that will satisfy this equation. That's what it means, depending upon value of c1, c2, c3. Right? So we'll move on to third problem. Solve. So solve d cube y by dx cube minus 9 times d square y by dx square plus 23 times dy by dx minus 15y is equal to 0, right? So clearly this is a linear differential equations of constant coefficient and you can see the RHS is 0, right? RHS is 0. So that means it falls under type 0, right? So solution. It falls under type 0. So for type 0, this is same as d cube minus 9d square plus 23d minus 15 of y is equal to 0, right? You just take this y common all, right? Y. Now, first, the solution is given by y is equal to complementary function alone, right? Okay. Now, how to find complementary function? First, you find the auxiliary equation, which is m cube minus dm square plus 23m minus 15 is equal to 0, right? This is a third degree polynomial. You will have 3 roots, right? You need to find the roots. So you can find the first root by trial and error method, right? Trial and error method. So what is the first root here? If you put 1 here, it is not root, right? If you put 1 here, sorry, this is 9. I think if you put m here, if you put m is equal to 1, it will be a root, right? So 1 minus 9 is minus 8. Minus 8 plus 8 is 0. Super. So clearly, m is equal to 1 is a root, right? So in that case, you find other 2 roots by L method. So 1 minus 9, 23 minus 15. You need to put 0 first here. 1 plus 0 is 1. 1 into 1 is 1. You need to add it up here, right? Minus 9 plus 1 is minus 8. 1 into minus 8 is minus 8. 23 minus 8 is 15. 1 into 15 is 15. This will be 0. You will always get 0 here if this number is a root. That means the other 2 roots are the solutions of m square minus 8m plus 15 is equal to 0, right? This is constant. This is quotient of m square. This is quotient of m. This is constant term. So find the other 2 roots. So minus b plus or minus root of b square minus 4 times a into c divided by 2 times a. So a plus or minus, this will be square root of 64 minus 60, right? 64 minus 60 is 4. So 4 by 2. So 8 plus or minus 2 by 2. So 8 plus 2 is 10. So 10 by 2 is 5. 8 minus 2 is 6. 6 by 2 is 3. Okay. Again, we are getting 3 distinct roots. The complementary function is given by c1 e power first root, c2 e power 3x, c2 e power 5x. The solution is y is equal to c1 e power x, c2 e power 3x, c3 e power 5, right? So type 0 is very easy. If you have type 0, the solution is y is equal. Usually you will have cf plus pi, but if you have type 0, the solution is only this, right? Okay. Now we'll move on to fourth problem now. To solve d power 4 by dx power 4 minus 5 times d square y by dx square plus 4y is equal to 0, right? This is same as same as d power 4 minus 5d square plus 4 of y is equal to 0, right? The solution is given by, solution is y is equal to complementary function because it is type 0, because the RHS is 0. Now to find auxiliary, first you find the auxiliary equation. So what is the auxiliary equation? Is m power 4 minus 5m square plus 4 is equal to 0, right? We need to solve this equation. Fourth order, right? Usually the second and the third problem, we have third order. Here we will have 4 roots, right? Because it's a polynomial of degree 4. So how to solve this? Very easy, right? So put t is equal to m square. So this will be t square minus 5t plus 4 is equal to 0. Now solve this equation here. So t is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. So 5 plus or minus 24 minus 16. Sorry, 25 minus 16 is root 9. Root 9 will be 3 divided by 2. So 5 plus 3 by 2. 8 by 2 is 4. 8 by 2 is 4. 5 minus 3. 2 by 2 which is 1. So therefore t is 2 or t is equal to 1. Now replace t is equal to m square. M square is equal to 2 or m square is equal to 1. So that means m is equal to plus or minus root 2 and this m is equal to plus or minus 1, right? So you will have this, oh sorry, 4 1, right? 4 4. T is 4, right? So m square is 4 plus or minus 2. Therefore the roots are 1 minus 1, 2 minus 2. All are distinct, right? All are distinct. The complementary function is given by c1 e power 1x, c2 e power minus x, c3 e power 2x plus c4 e power minus 2x. So you can extend this also, right? I have given you 3 distinct root. If it is 4 distinct root means you will add c4 e power m power 4x. If it is 5 distinct root means you will have another term which is c5 e power m5x, right? Very simple. Just have to extend from now on. So we have 4 roots and 4 are distinct, right? Therefore the solution is y is equal to c1 e power x, c2 e power minus x, c3 e power 2x plus c4 e power minus 2. So type 0 is very easy. You have a linear differential equation with constant coefficient, right? With constant coefficient and RHS is 0 and RHS is 0. I'll move on to the problem. Solve d square y by dx square minus 4 dy by dx plus y is equal to 0, right? This is second order, so we'll have 2 roots only. Same as d square minus 4d plus 1 of y is equal to 0, right? Therefore the solution is y is equal to complementary function. Now to find complementary function, you find the auxiliary equation. What is auxiliary equation? Is m square minus 4m plus 1 is equal to 0, right? M square minus 4m plus 1 is equal to 0. Always use the quadratic formula for finding the roots, right? So don't go for factorization method. So always go for quadratic formula, right? So minus b. So minus b plus or minus root of, here a is 1, b is minus 4, c is 1, right? Ax square plus bx plus c. So b square minus 4 times a into c divided by 2 times a. So this will be 4 plus or minus 16 minus 4, right? 16 minus 4. So you will have this to be root 12. Root 12 by 2. This is 4 plus or minus 2 root 3, right? By 2. So if we take 2 outside, you will have 2 plus or minus root 3. After this is real only, right? Real and distinct. Real and distinct root. So 2 plus root 3, 2 minus root 3. The roots are real and distinct, right? The roots are real and distinct. Roots are real and distinct. So in that case, your complementary function is C1 e power m1x, C2 e power m2x, right? Don't think it is complex, right? It is real root only. If we have only I here, right? If you have negative in square root, then only we have complex root, right? So again, y is equal to CF, right? General solution is y is equal to complementary function, which is same as this, right? So y is equal to C1 e power 2 plus root 3x, C2 e power 2 minus root 3 into x. Super. So move on to next problem. Solve d cube minus d square minus d minus 2 of y is equal to 0, right? Usually they give like this, we'll convert to this, but they are given this directly. So in that case, we know this is a linear differential equation of constant coefficients and it is type 0. Therefore, the solution is given by y is equal to CF, right? It's a solution, the general solution. Now, to find complementary function, you need to solve the auxiliary equation, which is m cube minus m square minus m minus 2 is equal to 0, right? Again, if you put m is equal to, usually when you are finding a solution by trial and error method, usually we'll have one solution from this, right? Minus 3 and plus 3. Usually we'll have one solution from this, right? Because it is not that easy to solve the cubic equation without knowing one root. So that one root can be any one of this, right? Any one of this maximum. So if you put m is equal to 2 here, clearly m is equal to 2 is a root, right? 2 cube is 8. 8 minus 4 is 4. 4 minus 2 is 2. 2 minus 2 is 0. The other two roots are found by L method. So 1 minus 1 minus 1 minus 2. So 0 here. 1 plus 0 is 1. 2 into 1 is 2. 2 minus 1 is 1. 2 into 1 is 2. 2 minus 1 is 1. Is 0, right? So we'll finish this quickly, right? And I'm getting lots of disturbance. Right. Finish this class quickly and then we'll have this type 0. So we'll finish type 0 alone. So I thought of completing type 0, type 1, type 2 all in this class. But we will stop after completing type 0. The other two roots are, solving this equation m square m plus 1 is equal to 0, right? So that means m is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. So minus 1 plus or minus root of minus 3 by 2, right? Same as minus 1 plus or minus square root of I square into 3 by 2. Because I square is minus 1, I'm writing minus like this. Minus 1 plus or minus I root 3 by 2, right? That means we have the roots are 2 minus 1 plus or minus I root 3 by 2. So we have one distinct root. The other two roots are complex, right? Remember this, very important. So for one distinct root, we will write C1 e power 2x. And for this complex root, we will have what? This of the form alpha plus or minus I beta, right? So alpha is minus 1 by 2. Beta is root 3 by 2. So e power alpha x, C3, let us C2 because RC1 is already used. C2 cos beta x, C2 cos beta x, C3 sin beta x, right? This is very important. For this distinct, we have only one which will be distinct, C1 e power 2x, and these two are complex, so you need to add it up both, right? So in that case, C1 e power 2x, alpha is minus 1 by 2, right? Alpha is minus 1 by 2, beta is root 3 by 2. Here, right? Alpha plus or minus I beta. Look at Yeah, right. We'll move on to next problem. Is it clear? Clear, right? Wrong problem. See, you just have to remove all this table. Depending upon the values of auxiliary equation, you need to combine. For example, if you have the roots like, you have the roots like 2, 2, let us, if you have the roots like 2, 2, 3. So for these two real roots, CF will be this, right? C1 plus C2 e power 2x. And this will be distinct. So you need to add it up C1 e power 3x. So for this, your complementary function will be C1 plus C2x into e power 2x, because these two are real and equal. And this one we have distinct root. So let us write C3 e power 3x. Depending upon the roots, you just have to write it down from here, right? If you have one, okay, let us write, if you have one distinct root, so if you have one distinct root, where complement function is, let us say m1. It is c1 e power m1x. That's it. That is what we are writing here, right? Suppose if you have roots like I, okay, let's solve the problem, then you will have more clarity. Is it clear, right? So depending upon the nature of roots, you have to find, you have to choose complementary function from this table, right? Okay. We'll move on to 7th problem. Solve d power 4y divided by dx power 4 plus 13 times d square y by dx square. See, the method of finding complementary function is very important. I have said that whatever RHS may be, the method of finding complementary function is same. The only thing is, for finding this PI only, it will vary depending upon the RHS. Now we are in type 0. So for type 0, you don't need to find particular integral. Now what is type 0? Type 0 is RHS is 0. Right? In that case, your solution is only CF alone. Right? So to find CF, we know, replace capital D by M. You will have a polynomial of degree n. Solve that, you will have n roots. So here we have polynomial of degree 2, you have 2 roots. So both are distinct. If depending upon the roots, you find the CF from this table, right? This table is very important. Okay, solution. This is same as d power 4 plus 13d square plus 36y is equal to 0. Right? Now we'll solve this equation. Now what is the general solution? The general solution is given by y is equal to CF alone. We don't need to add PI. You don't need to add plus PI because the RHS is 0, right? Because RHS is 0. Okay. Is it clear? Or is there any doubt? Okay. What is auxiliary equation? The auxiliary equation is given by m power 4 plus 13m square plus 36 is equal to 0, right? So put t is, when we solve this equation, so put t is equal to m square. That will be t square plus 13m plus 36 is equal to 0, right? So t square plus 13m minus 36 is equal to 0. Plus 36 is equal to 0. So we'll solve this. So t is equal to minus b plus or minus root of b square minus 4 times ac divided by 2 times a minus 13 plus or minus root of 36 into 4. So 24. 12 plus 2 is 144. So 169 minus 144 is 25. Root 25 by 2. So minus 13 plus or minus 5 by 2. So minus 13 plus 5 by 2 will be minus 13 plus 5 is minus 8 by 2. So minus 8 by 2 is minus 4. Minus 13 minus 5 is minus 18. Minus 18 by 2 is minus 9. Right? Therefore, t is equal to minus 4 or t is equal to minus 9. So what we know, t is m square. M square is equal to minus 4 or m square is equal to minus 9. M is equal to plus or minus 4i, right? Because you have minus here. Here, right? So what is square? M is square root of 4i. Square root of minus 4i. M is square root of minus 4. This m is square root of minus 9. I can write this minus as I square plus or minus 4i. If we take this I square out, we will have I. and this m is equal to plus or minus 9i. Therefore, the roots are 0 plus or minus 4i is one root, 0 plus or minus 9 is another root. So 0 plus 4i, 0 minus 4i. So both are what? Two distinct complex root, right? It falls under the case um, two two pairs of distinct complex roots, right? Two pairs of distinct complex roots. Here alpha is 0, gamma is 0 in our case, right? So you just compare this with alpha. So alpha plus or minus I beta, gamma plus or minus I delta, right? So in that case, what will be your C1 and C2? Sorry, what will be your characteristic function? Right? Your characteristic function is same as your general solution. So C1 e power alpha x, right? C1 e power alpha x into C1 cos beta x plus C2 sin beta x plus e power gamma x C3 cos beta x plus C4 sin delta x or beta x, right? Very simple to write the characteristic function. This is same as y is equal to the e power 0 is 1. So we'll have C1 cos 4x, C2 sin 4x, C3 cos 9x, C4 sin 9x is the required solution, right? So you have two pairs of distinct complex root. Both are all are distinct, right? 0 plus 4i, 0 minus 4i, 0 plus 9i, 0 minus 9i. All are distinct only, right? Super. So move on to eighth problem. Is there any doubt up to now? Okay. So solve e power 4 plus 4 is equal to 0, right? E power 4 y. E power 4, let's write in this solve e power 4 by dx power 4 plus 4y is equal to 0, right? This is the fourth order linear differential equation with constant coefficient. This is type 0 because RS is 0, right? Okay, RS is 0. Now, so the solution is given by, the general solution is given by y is equal to complementary function, right? Y is equal to complementary function. So to find complementary function, first we need to find the auxiliary equation, which is the root of m power 4 plus 4 is equal to 0. Right? This is same as e power 4 plus 4 of y is equal to 0. Right? Both are same only. Both are same only. Okay. So when we solve this equation, right? So put t is equal to m square. Put t is equal to m square. So in that case, this will be what? M square plus 4 is equal to 0. So m square is equal to minus 4. So m is equal to square root of minus 4. So m is equal to plus or minus 2i, right? This is same as root of 4i square. I square is minus 1. So if I bring this I outside, it will be I. Sorry, if I bring this I square outside, it will be I. Root 4 is plus or minus 2. Now replace, um, you replace, update. Okay. Put d is equal to m square, t square, right? So t square, t square, t is equal to plus or minus 2i. That means t is equal to 2i or t is equal to minus 2i. Now replace t is equal to m square. M square is equal to 2i or m square is equal to minus 2i. So m is equal to square root of 2i and this m is equal to square root of minus 2i, right? M is equal to square root of minus 2i d square. Yes, right? I made some mistake. You have d power 4 plus 4 is equal to 0, right? You have d power 4 plus 4 Yes, we have made mistake, I think. 4 plus 4. What about 2 equal power? See, it is not possible to solve from here, right? Because we have minus minus here. Okay, so what we will do is, so we'll approach some other method, right? We need to solve m power 4 plus 4 is equal to 0. So we'll go for some other method, right? Okay, so what we'll do is m power 4. So we know a plus b whole square is a square plus b square plus 2ab, right? So a plus b whole square minus 2 times ab is a square plus b square. So we will write this as m square whole square plus 2 square is equal to 0, right? So a square plus b square is a plus b whole square minus 2 times ab, right? So this is a, you expand this, right? M square plus 2 whole square. Okay, so we'll keep this as it is, right? This is m square plus 2 whole square. This is 4m square, right? Now m square plus 2 whole square. This I can write this as 2m whole square. Now a square minus b square. So a plus b into a minus b, right? A square minus b square is a plus b into a minus b. So the roots are solving this and this. So you just solve this equation. So for this the roots are minus b plus or minus root of b square minus 4ac divided by 2 times a minus 2 plus or minus will be square root of minus 4, right? This minus 2 plus or minus 2i by 2. So if I take this 2 to cancel, so minus 1 plus or minus I are the two roots for this equation. So solve this equation, you will have m is equal to minus b or minus root of b square minus 4 times ac divided by 2 times a. We will have 2 plus or minus 2i, right? We will have a 4 minus 8 minus 4. So minus 4 I can write this as 2i, right? So 1 plus or minus I. So again you can see the roots are two distinct complex root. Yes or no? Two distinct complex root. Two distinct complex roots. So you will have alpha plus or minus I beta, gamma plus or minus I delta. Alpha is 1, beta is alpha is minus 1, beta is 1, gamma is 1, delta is also 1. So what is the solution? Solution is y is equal to solution is given by y is equal to e power alpha x c1 cos beta x plus c2 sin beta x plus e power gamma x c3 cos beta x plus c4 sin beta. Is it clear? Is it clear, right? Power I into 1x. E power alpha x. So here is 1. right? Alpha is -1, beta is 1. So this is the required solution for this problem. Clear, right? So to solve m power 4 plus 4 is equal to 0, we need to go by this method. Okay. Now we move on to second problem. We have ninth problem. To solve e power 4 by divided by dx power 4 plus 5 into d cube by dx cube plus 6 into d square y by dx square minus 4 dy by dx minus 8y is equal to 0, right? So it is a fourth order linear differential equation with a constant coefficient, right? With a constant coefficient. So we will do this. Is it clear up to now? Very easy. We are solving this. The solution is y is equal to because we don't have pi, only we need to find cf. So depending upon the nature of see Nagaprakash, you have to, there is no any formula for solving a fourth order equations, right? That is what I'm saying, right? If you have equation like d power 4 plus d cube plus 9, very good question, but we don't have any general formula. For second degree, we have formula, right? Quadratic formula. For third degree or fourth degree, we don't have any formulas, right? In an exam point of view, they will only ask the question like this only. If not, one root can be found easily by trial and error method. So in your question, that is d power 4 plus d cube plus 9. So we cannot put t is equal to m square or something, and we cannot find the first root also very easily, right? So they won't ask question like that. Usually they will ask question like put t is equal to m square. In that case, it will be reduced to quadratic, or it will be like one root is easy to find, right? Yes. Just now I'm seeing your comment. So we'll solve this equation now. This is same as d power 4 plus 5d cube plus 6d square minus 4d minus 8 of y is equal to 0. Right? So you will have, here we have a fourth order differential equations, and all are, you can easily see one is a root, right? So clearly one is a root, right? Because 1 plus 5 is 6, 6 plus 6 is 12, 12 minus 12 is 0. So to find other three roots, go for quadratic. So 1, 5, 6, minus 4, minus 8, 0, 1 plus 0 is 1, 1 into 1 is 1, 5 plus 1 is 6, 6 into 6, 1, 6 plus 6 is 12, 12, should be 8, should be 8, should be 0, right? So the other three roots are the solutions of x cube or a m cube, right? M cube plus 6m square plus 12m plus 8 is equal to 0. Now again you can see here minus 2 is a root, right? So clearly that is what I have said, right? In 1 minus 1, 2 minus 2, 3 minus 3, you will have one root. Most of the cases. If you put m is equal to minus 2 here, you will have minus 8 plus 12. Minus 8 plus 12 is 4. And if you put minus 2 here, if you put minus 2 here, this will be minus 8. And this will be 6 into 4 is 24. 24. And if you put m is equal to minus 2 here, we will have minus 24 plus 8. You can see it is a root. So the other two roots are found by L method now. So 1, 6, 12, 8, minus 2. So 0, minus 2, 4. 4 into minus 2 is minus 8. This will be 4. It will be minus 8, 0. Right? The other two roots are solution of m square plus 4m plus 4 is equal to 0. Solve this. M is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. So minus 4 plus or this will be 0, right? Divided by 2. So we will have minus 2 plus 0, minus 2 minus 0. So minus 2 are the roots. Therefore, the roots are already we have 1, already we have minus 2, and we have these two. So 1, minus 2, minus 2, minus 2. So we have one distinct root, 3 equal roots, right? What will be your CF? So for one distinct root, we will write C1 e power 1x, and for these 3 equal roots, C1, let's start with C3, right? C3 plus C4x. We'll start with C2, C2 plus C3x plus C4x square into e power mx. That's it, right? So for we have 3 equal and 1 distinct. So for 1 distinct root, we'll put C1 e power 1x. And for these 3 equal roots, we know formula, right? C1 plus C2 plus C2x into e power mx. So for 3, C1 plus C2x, C1, C2, C3 are just constant, right? Since I already used C1, I'm starting with C2, C3, C4. C is yes, so C2 plus C3x plus C4x square into e power minus 2x. This is general solution. Is it clear? Can you move on to the next problem? On 10th problem. So solve d square x by dt square minus 3 dx by dt plus 2x is equal to 0, given that t0, given that when t0 x0 and dx by dt is 0. So why they have given this condition? Because to find the arbitrary constant C1, C2 and so on that we are using, right? Usually in here you can see we are having this constant, right? C1, C2, C3, C4. We don't know any of these values, but here they are given this initial data, initial condition to find out the value, right? Okay, we'll do this. So the auxiliary equation is given by this also what? Linear differential equation of constant coefficient, right? Okay. And it comes under what? Type 0. So you can see when t is 0, x is 0 and dx by dt is 0, right? When t is 0, these two happens. That is why you have to see. When t is 0, x is also 0 and dx by dt is 0, right? Okay. So this is same as m square minus 3m plus 2 is equal to 0. M is equal to minus b plus or minus root of b square minus 4ac divided by 2 times a. So 3 plus or minus 1 by 2, right? Root 8. Sorry, root of 9 minus 8 is 1. So 3 plus 1, 4 by 2. 4 by 2 is 2. 3 minus 1 is 2. 2 by 2 is 1. Therefore, the roots are real and distinct. Therefore, your y is same as characteristic function. This is C1 e power m1x plus C2 e power m2x. Therefore, the solution is C1 e power x, C2 e power 2x. This is the solution now, right? This is the solution now. Actually, here the independent variable is t, right? Usually we will have dy by dx, but we have t here. So instead of writing x here, we will write here solution is x is equal to, right? Because x is the solution here. So you just write x is equal to cf. X is equal to c1 e power, instead of x you put t, m1t, m2t, because you can see the independent variable is t, right? m1t, m2t. So solution is c e power t plus e power 2t. This is a solution, right? Therefore, solution is x is equal to c1 e power t, c2 e power 2t. Usually you lift at this stage itself, but since they are given this initial condition, you need to find the value of c1 and c2 now. So it is given that when t is 0, x is 0, right? So when t is 0, x is also 0. So substitute here. So 0 is equal to c1 e power 0, c2 e power 0. This implies c1 plus c2 is equal to 1. Sorry, 0, right? Call this as equation number 1. Now second condition they are given is when t is 0, dx by dt is also 0, right? Now what is dx by dt? So from here you find dx by dt, right? So c1 e power t plus c2 e power 2t into 2, right? Now when t is 0, dx by dt is 0. So put t is equal to 0. So dx by dt is equal to 0. So we will have dx by dt is 0. T is also 0. So c1 plus 2c2, right? So when you put 0 here, e power 0 is 1, e power 0 is 1. So 2c2 plus c1 is 0. So you will have second equation, t1 plus 2c2 is equal to 0, right? So t1 plus 2c2 is equal to 0. So you need to solve these two equations, right? So solving 1 and 2, whether it is possible, whether a non-trivial solution is possible, you can see this is it is a homogeneous equation, right? It is a homogeneous equation, linear equation, right? So when you see the determinant 1, 1, 1, 2, non-zero determinant, that means what? Only trivial solution is possible. This implies C1 is also 0. Linear algebra, right? Very simple. Linear algebra. You are solving system A is equal to 0. And when determinant of A is not equal to 0, only trivial solution is possible. Only trivial solution is possible. That is 0 is the only solution. Therefore, C1 and C2 are 0. So that means, what about your Y? So Y is 0 e power t plus 0 e power x, right? Let us call this call be equal to 1, right? This is solution, right? Therefore, the solution is x is equal to, that means what? 0 solution is the only solution that satisfies this equation, right? So x is equal to 0 is a solution. That is, we put x is equal to 0 only, then both will be 0. That is, what is the second derivative of 0? It is 0. This way it is 0. It is 0. So 0 minus 0 plus 0 is again 0. 0 is the only solution for this equation, right? If you have some non-zero C1, C2 means that will be the solution. But in this problem, both C1 and C2 are 0, right? Okay, super. Now we'll move on to second problem. Solve seventh problem, right? Solve d square y by dx square plus y is equal to 0, given that the y value is 2 for x is equal to 0 and y value is minus 2, y value is minus 2 for x is equal to pi by 2. This is what they have given, right? When you solve this equation, so why they have given this data? Just to find the arbitrary constant, right? Just to find out the arbitrary constant. Please repeat the procedure in. What is your note? Okay, you need to solve this system, solve the equation. This is a homogeneous equation. Have you solved? Have you seen linear algebra lectures? Have you seen linear algebra lectures? This is a homogeneous equation, homogeneous system of linear equations. What is the solution here? C1 has to be minus C2. You cannot find C1 and C2 such that it satisfies both the equation, because the determinant of this is not equal to 0. In that case, you will have only trivial solution. If it is 0 means you will have infinitely many solutions. It's a very 11th standard linear, 11th standard max. Okay, now we'll solve this equation now. These are linear differential equations with a constant coefficient and it is type 0 because RHS is 0. So therefore, what is the auxiliary equation? Is m square plus 1 is equal to 0. So that means m is equal to plus or minus I. So CF is what? 0 plus or minus I. Therefore, CF is e power alpha x, e power alpha x, e power alpha x, C1 cos beta x, C2 sin beta x, e power this is 1. So we will have C1 plus C1 cos x, C2 sin x your CF. Therefore, the solution is y is equal to C1 cos x, C2 sin x, right? Now to find C1 and C2, it is given that y is 2 when x is 0, right? Y is 2 when x is 0. So y is 2 when x is 0. C1 cos 0, C2 sin 0. Sin 0 is 0, cos 0 is 1. Implies the value of C1 is 2. Right? And it is given that y value is minus 2 when x is equal to pi by 2. It will be minus 2, y value is minus 2 and x is pi by 2. So cos pi by 2 is 0, sin pi by 2 is 1. We will have C2 to be equal to minus 2. Right? Therefore, solution is y is equal to C1 cos x plus C2 sin x. C1 is 2 cos x, C2 is minus 2 sin x. This is the solution. You can substitute here, right? Just find second derivative for this and add y, you will get 0. You can check it out, right? This is a solution, right? Solution means what? It satisfies this equation, right? For example, you just see. Now what is y? Y is this, right? Now what is dy by dx? What is dy by dx? Differentiate this. So 2 into minus sin x, 2 into cos x. This is dy by dx. Now what is d square y by dx square? You can differentiate once again. It will be minus 2 cos x plus 2 sin x, right? So this is d square by dx square plus y. You add it up plus y. What is y? 2 cos x minus 2 sin x. You can see when you add it up, you will get 0. That means d square by dx square plus y is 0. That means what? This is the y you need. Such that if you differentiate that y twice and add that y, you need to get 0 as an answer. That means this is a required solution. Is it clear? I think there is a problem in the stream. Please wait a minute. I think there's a problem in the stream. I'm doing 11th problem now. Okay. You are seeing 11th problem only, right? You are seeing 11th problem only, right? The screen, there is some problem, I think. The live, you are seeing 11th problem only, right? Okay, thank you, thank you. Okay, so we are done with 11th problem. So now we'll move on to 12th problem. I think we can start this type 0, right? I think from now on you can do any problem on type 0. So if you want, I can also give you some exercise problem based on type 2. We will solve one more problem and then we'll wind up. So solve t square. We'll solve this one more equation and then we'll wind up. Y double dash minus 2y dash plus 10y is equal to 0. It is given that y of 0 is 4 and y dash of 0 is 1, right? Solution. This is same as what? This is same as d square y by dx square minus 2 dy by dx plus 10y is equal to 0. This is same as d square minus 2d plus 10 of y is equal to 0. The solution is given by y is equal to CF alone because it is type 0. Now what is CF? You find the auxiliary equation which is m square minus 2m plus 10 is equal to 0. So m is equal to minus b plus or minus root of d square minus 4ac divided by 2 times a. So 2 plus or minus square root of minus 36 by 2. So 2 plus or minus 6i by 2. So if I take 2 outside, 1 plus or minus 3i, right? So you will have what? Alpha plus or minus I beta. So you will have one pair of complex root, right? One pair of complex root. So that means the solution is y is equal to CF e power alpha x c1 cos beta x c2 sin beta x, right? Therefore, the solution is e power x c1 cos 3x plus c2 sin 3x. This is the solution, right? Call this as 1. Now to find c1 and c2, they are given the data. This solution is a function of x, right? This solution function of x. So y of x is e power x c1 cos 3x c2 sin 3. This is the solution. Now to find c1 and c2, they are given the initial condition. We will use initial condition, right? Now to find c1 and c2, they are given that y of 0 is 4. So when you put x equal to 0, you will have e power 0, c1 cos 0, c2 sin 0 is 4. So e power 0 is 1, cos 0 is 1. So we will have c1 to be equal to 4, right? We have c1 to be equal to 4. Now to find, to use another data, we need dy y dash, right? Now from 1, what is y? From 1, y is c1 e power x cos 3x plus c2 e power x sin 3x, right? And we know c1 is 4, so we will replace this c1 to be equal to 4. Now we will find y dash. So what is y dash of x? So 4 into, you need to apply product rule. So e power x will be minus sin 3x into 3 plus cos 3x, derivative of e power x is e power x. Now you keep the c2 as it is, differentiate this, keep this e power x as it is, will be cos 3x into 3 plus you keep sin 3x now, differentiate e power x. This is the y dash of x. Now it is given that y dash of 0 is 1, right? So what is y dash of 0? You substitute 0 here. So you will have 4 into, if you put 0 here, you will have what? Minus 3 e power 0 sin 0 plus cos 0 e power 0. I'm just putting x to be equal to 0. So c2 will be 3 e power 0 cos 0. System will be 0, right? Because sin 0 into e power 0 is equal to 1. Because y dash of 0 is 1. So this will be 0. So cos 0 is 1, e power 0 is 1. So 4 into 1 is 4. And this again 3, right? It will be 3c2 is equal to 1. So 3C2 is equal to 1 minus 4, 3C2 is equal to minus 3, C2 is equal to minus 1. So we have found the two constant. Therefore, general solution is y is equal to CF from 1, right? So from 1 we have the general solution e power x c1 cos 3x c2 sin 3x. So e power x c1 is 4. So 4 times cos 3x, c2 is minus 1 sin 3x. This is a required solution, right? You can check it out, right? How you can check? You substitute this y here, differentiate this y twice, and differentiate once and multiply minus 2 and multiply 10 with this y and add it up, you'll get 0 as an answer. You can check it out, right? So far what we did is we have started a linear differential equations, right? We have started linear differential equation with a constant coefficient. So how to solve? What is the general format? It is a naught dn y by dxn plus a1 dn minus 1 by dx minus 1 and so on up to a and y. This is the linear differential equation of nth order. Usually in exam point of view, you will have second or third or fourth order. Now the solution is given by y is equal to characteristic function plus particular integral. Now for finding characteristic function, whatever the RHS x may be, or finding CF is same for all, right? Depending upon the RHS, you need to find particular integral depending upon the RHS. Now I have said you, I have given the formula for finding characteristic function, right? Okay. Now type 1, type 0. What is type 0? RHS is 0. That is your x term is 0. In that case, the general solution is y is equal to CF alone. Y is equal to CF alone, right? Now what is CF? Right? Now what is CF? CF is you need to find by depending upon the roots of auxiliary equation, you need to write the CF. So here you can see if the roots are real and distinct, you will have one characteristic function. If the roots are real and distinct roots, 3 distinct roots, 2 equal roots, 3 equal roots, 1 pair of complex roots. So depending upon this, you need to write the complementary function, right? So we have solved almost 12 problems based on this type. Next class, we're going to move on to type 1. What is type 0? Type 0 is RHS is 0, right? RHS is 0. The next class, we're going to move on to type 1. The type 1 will be RHS. This x will be of the form e power ax. Will be of the form e power ax, right? What is type 2? RHS is of the form sin ax or cos ax, right? Here we have RHS is 0 in type 0. In type 1, we have e power ax, e power 2x, e power 3x, like that. In type 2, we will have sin ax, or let us say a is any number, right? Sin 3x, sin 4x, sin 5x, or cos ax also, right? So in the next class, we will be moving on to type 1 and type 2. For type 1 and type 2, you will have pi, right? In type 0 only, you don't have pi. But for type 1, type 2, and so on, you will have what? Solution is y is equal to complementary function is particular integral. There is a separate method for finding particular integral when it falls under type 1. There is separate method of finding particular integral when it falls under type 2, and so on up to type 5. Right? Next class we will solve type 1 and type 2, where RHS is of the form e power ax. It is type 1. And type 2 is sin ax or cos ax. A is a real number, you can put whatever you want. Right? So is there any doubt up to now? So we will wind off this session. So in the next class we'll move on to actually I thought of finishing type 1 and type 2, but we are finished only type 0. Right? Type 0 is RHS is 0. Okay. So that's it. So we'll wind off. Thank you. Right? Thank you.